Welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. This course, Elements of Mechanical Engineering, is offered to civil and aeronautical engineering students in BTech course. And the topic for today is working of a nuclear power plant. In this lecture, we are going to see how a nuclear power plant will work, what are the basic components of any nuclear power plant, and the different aspects regarding nuclear energy in India as well as the world. In the first module, we were studying about the sources of energy. There are many sources of energy, starting from conventional and non-conventional energy sources, like the sources which are readily available in the nature. They are called conventional and they are also non-renewable. Once they are exhausted, we cannot retrieve them. And similarly, second kind of energy sources are renewable. These are readily available in the nature, like solar energy, etc., where these energies can be renewed. They can be used many times. Still, they are not exhausted at anymore. Now we'll see the nuclear power reactors. What is the trend of nuclear power reactors in India and the world? So there are about 440 nuclear power reactors in 31 countries. We know nuclear energy is one thing where every country wants to show their power by using nuclear energy or nuclear research. Because this nuclear energy, which will be developed by using some kind of radioactive elements, when these radioactive elements are reacted at the correct chain reactions, they will form enormous amount of energy or heat. This heat can be used to generate electricity. We know the working of a thermal power plant, where we will use coal for boiling the water. When the water is boiled, it forms a steam. When this steam is made to form a high pressure steam is when it is fed on the high turbine or any turbine. What happens is this steam will make the turbine rotate. The turbine, which is in connection with the generator, it will produce electricity. Okay. Now, this is what generally happens in thermal power plants, where the energy is being supplied by coal. Now, what happens in nuclear power reactors? The source of energy is nuclear power, where we will use radioactive elements for generating the heat. And this heat is used to boil the water, where the water is converted from liquid state to gaseous state, where it is converted into steam. This steam is made to fall on the turbines at high pressure and velocity. Due to this, the turbines will rotate and we will get electricity with the help of a generator. Because of this enormous power, because there is very small amount of raw material required for the working of any nuclear based power plant. So the nuclear power plants are very well established around the country. Not only the advantages, there are some disadvantages where the nuclear power plants are failing. Like, if the chain reaction of this radioactive element is not stopped, what happens? The entire nuclear power plant will be blasted. The chain reaction, if it is not controlled, it will keep on going and it will be like a nuclear bomb. Not only nuclear power plants, all countries around the world are trying to develop nuclear weapons, which can create a huge destruction with a small amount of payload. Very small bomb can create a large destruction. So there are around 30 more nuclear power plants are being constructed, and once they are completely constructed and completely operational, we will get around 16% of world's electricity under the nuclear power source. 16% of the entire world electric production will be under nuclear power plants. Mostly, the main component of the world's electricity is generated from hydraulic or thermal power plants. Now, the nuclear power plants are increasing day by day, where we will get most of the electricity, around 16%, and they produce a total of 351 gigawatts of electricity. This is very big number. 351 gigawatts of electricity is very huge amount that a single nuclear power plant is big enough to run one state's power. Like if you take the example of a state like Andhra Pradesh or Telangana, the entire state electric supply can be given by a single nuclear power plant. That is the capacity of a nuclear power plant when it is run at full stretch. So these are some of the countries where the nuclear power plants are being installed and used. Mostly we can see US, Germany, UK, and Asia, India. So if you see these countries, Western Europe is also has a large number of nuclear power plants. So all these countries established large number of the nuclear power plants where they are using nuclear energy for the production of electricity. So in the North American region, we can see there are 109 plants and still more are being installed where they are used for production of electricity. And 21 are there in Germany, and UK has 12 nuclear power plants. Western Europe has many, as high as 126 nuclear power plants are there. And in Japan, there are 44, and in Asia, 66 power plants are there. And coming to India, there are 22 power plants in India, which comes under Ministry of Atomic Research. And out of the 22 nuclear power plants in India, around 10% of India's electricity is being developed in this nuclear power plants itself. Mostly this electricity is used for industries, and some percentage of this electricity developed by the nuclear power plants in India is used by domestic usage. Now we'll see the trend or the different locations where the nuclear power plants are present around the world. We can see mostly the nuclear power plants are present in Northern America and Europe region. Most of the nuclear power plants are present in this area only. Remaining all places will have a very short number of power plants. Whereas in Japan, there is a large number of power plants are there. In the previous slide, we can see around 44 power plants are there in Japan. Japan is a very small country, yet it has large number of nuclear reactors where they can produce electricity for the industrial purpose or the domestic purpose. Now, we'll see what is a nuclear reaction and how does a nuclear fission reaction will work. Now, we are telling that there are some radioactive elements. When these radioactive elements are made to react with some kind of when heat is supplied to these radioactive elements, they will create some reaction. They will form a chain reaction called nuclear fission reaction, where one element of the radioactive element will be separated into 2 or 3 parts. And again, these 2-3 parts again will be divided into some more 3 to 4 parts. Okay, this chain goes on increasing and enormous amount of energy will be released because of the formation of new molecule. Every new molecule will give out a lot amount of heat. Now this heat can be used to boil water, or we can use that for generating of steam. Now see here, we have uranium molecule here, uranium 235, where this uranium is used to, when some kind of slow moving energy or slow neutron means we are supplying some kind of energy in the form of neutrons. When this neutron hits the uranium nucleus, what happens? It disintegrates the uranium molecule into two molecules, two parts. One is fast neutron, and another one is a second kind. There are two fast neutrons evolving from the uranium nucleus. Okay, when the neutron hits the nucleus, it gives two new neutrons. These two neutrons, when they are developed, what happens? They release some kind of energy in the form of heat. Now this heat will be absorbed by this moderator. Now what is moderator? Moderator is nothing but it is a controlling device which controls the flow of these neutrons. When the neutrons are not stopped, they will go on increasing by chain reaction, and thus they create large amount of heat. Now by using a moderator, we will control some of the neutrons and we will make them useful. The heat from the first step is absorbed, and some part of the energy in the form of slow neutrons, because we have observed some amount of energy from the neutrons that are being generated in the first step by moderator. What happens is the neutrons which are coming out of the first stage will become slow after the moderator has absorbed the heat. Now what happens is this slow neutron will again collide with another uranium nucleus, where it will be creating two more. Here we will see 1, 2, 3, 4. Here 4 neutrons are produced. In the starting stage, we have only one neutron which collided with the uranium nucleus, formed two neutrons. The energy from this reaction has been absorbed, and these two neutrons again reacted with the uranium nucleus and formed 4 more neutrons. Now these 4 more neutrons will go on to the next stage, where they will produce 16 neutrons. So if the moderators are not present, these two moderators are the controlling devices which control the temperature of the nuclear reaction. If the nuclear moderators are not there, what happens? This chain reaction will goes on, and enormous amount of energy will be developed in a very small area. This may causes explosion. Now we'll see some cases where this nuclear reaction is not at all stopped due to some mistakes done by the operators or failure of the machinery. So the nuclear reactions led to nuclear blast of the entire nuclear power plant. And these radioactive elements are so bad that even after 100 or 400 years ago, 400 years after the explosion, they will still produce radioactivity. They will give out some radiation. This radiation is very harmful for any human being or animals, plants, because they cause cancer. So the radioactivity of these elements is very bad to the surrounding people or the animals living around the nuclear power plant. So this is a nuclear fission reaction where we will have water moderator, where it will control the temperature of the entire reaction, and we have nuclear fission reaction, where a single molecule is divided into two every time it is come into contact with a neutron. Now this nuclear reaction is which we use in the nuclear reactor, where it produces a large amount of heat which is used by the water which boils, and this water is converted into steam. This steam is used in the turbines. Now we'll see the basic working of a nuclear reactor. Now before that, we'll see this one. So this is a outline or layout of the nuclear power plant. So the nuclear power plant generally contains this a large nuclear reactor is there. This is nuclear reactor, and after that it contains a turbine which is attached to the steam. The steam will come directly into the turbine, and then it contains a condenser where the water is generated from the steam. Okay. Now for this purpose, a cooling tower is attached. The cooling tower is the one which is responsible for cooling the steam and making it into liquid form again. Now see here, we'll see the working step by step. In the first stage, inside the nuclear reactor, we have a device. this is called a core. Core is where the nuclear chain reaction will take place. So inside this core, we will study this entire core in detail. Now we'll see the core. So this is the core part where the chain reactions will take place. So this is very important part because the failure of any small component of this entire system will lead to explosion, because we have to control the chain reaction in each and every stage, and after that, when the nuclear reaction has reached its end, it will goes on increasing the temperature, but we have to control it and we have to stop the reaction at some point in order to control the production of heat. See here, there are three main components of this nuclear reactor, where they are steam outlet, fuel rods, control rods. See here, if you see carefully in this diagram, this is a core grid. This part, this yellow color part is called the core grid. This is where the fuel is fed. The fuel we are using here is nuclear radioactive elements like uranium or thorium. Now what happens is, so here where the fuel will be taken and it is subjected to some kind of heat, which will make the starting of the chain reaction. And whenever the chain reaction has started, the heat will be starting from the chain reaction. This has to be absorbed by the rods, control rods. So these are the control rods which contains water in them. These control rods are moved into the nuclear chamber where they will absorb the heat. So the flow of water inside these control rods has to be constant. So the flow has to be constant so that the heat evolved from the chain reaction has to be taken away by the water inside the control rods. So the control rods will be moved inside when there is a chain reaction, and whenever the control rods moved inside, it absorbs the heat and it will stop the reaction. So whenever the reaction is stopped, we will no longer get heat. So that is when we will remove the control rods from the this assembly from the fuel where the chain reaction is taking place. When the reaction happens, when there is reaction, we will insert the control rods. What happens? The control rods will absorb the heat and the further reaction of the nuclear activity will be stopped. Now after some time, what happens is we have to remove the rods outside from the nuclear reactor, where the chain reaction will again start reacting and will produce more amount of heat. Now, depending on the amount of heat we need for the production or amount of chain reaction we have to control, depending on that, we will insert the rods inside or we will remove the rods from the nuclear reactor so that it will control the perfect working of the nuclear reactor. Now, there is a steam outlet at the top. So these are the steam outlets where the water inside the pipes will be converted into steam. So the steam is sent into a small narrow opening called nozzle. So these are all nozzles. Where the steam is entered into the nozzle, they will gain some pressure. So nozzle is nothing but it is a cylindrical pipe with narrow cross section at only one point. So whenever the gases or the steam reaches this nozzle, what happens is, due to the narrow cross section, when the steam is passing through this narrow cross section, the pressure of the steam will be increased. So that is when we will get velocity for the steam. So the pressure energy here, it is converted into velocity. So the steam which is coming out of the pipes will be flown onto the turbine, and on the turbine will be rotating. We'll see the remaining working of the power plant. So this is all working of the nuclear power reactor. So there are three parts. Center one is fuel rods, where the chemical radioactive elements will be placed, fuel rods. control rods are the rods which contains water, which will control the chain reaction of the nuclear reactor. And the steam outlets are the pipes which are fitted with nozzles, where the steam generated will be coming out at high velocity. So these are the three main components of the nuclear power reactor. Now we'll see the remaining layout of the power plant. Now we have seen this entire system. There is core, there are control rods, and here we have steam outlet. Okay, the three parts what we have seen now. These are core where the chain reaction takes place. These are the control rods. When inserted into the core, they will stop the reaction by absorbing the heat. And when the water around this place, this is heated and it is converted into steam. Now this steam is sent into a closed pipe from where it reaches the turbine. So the turbine is a movable mechanism where when the pressure is applied on the wheel, turbine wheel, it will rotate. So the turbine will be rotated by using the pressure energy, which is converted into velocity, and this velocity of the steam is used to rotate the the thermal turbine. So thermal turbine, which is in turn connected to a generator, it will produce electricity which can be fed to the transmission lines. So this is how the nuclear power plant works. And here, whatever the water that is coming out of the nuclear reactor or the turbine, so here we will get steam because the freshly generated steam will be fed on the turbine, and from there the steam is collected and it is sent into a condenser. Now this part is called condenser, where we will cool down the steam by flowing it into a cooling tower. Here we have this pipe, this is connected to a cooling tower. So in the cooling tower, what happens is the temperature of the steam is removed. Now the temperature of the steam is removed with the help of cold water. Now this cold water is again fed back into the condenser. This condenser again pumps the water back into the nuclear reactor. So the water we are using here in this process is reused because water is very scarce. Nowadays, the water has to be used wisely, and this water is recycled every time, like it forms steam after boiling and it will be touching the turbine blades, and after that it is collected in the condenser, and from condenser it is cooled in the cooling tower, and from cooling tower it is again pumped back into the nuclear reactor where it can be used any number of times. So this is the basic working of nuclear reactor. So here one important thing we have to study is that there are some nuclear disasters happened back in the day where some mistakes has happened. From these mistakes, some lessons have been learned, and these lessons have to be implemented in the current industries where there are nuclear reactors are there. So back in the year 1979, 3 Mile Island, it is a place where a nuclear reactor has been built. What happened there is 50% of core melted. So just now we have seen this is the core. This is the core where nuclear reaction will take place. In core, what happens is there is metal pipes inside which the nuclear elements like uranium or thorium will be placed. These elements, when they are subjected to heat, they will produce heat. Okay, when they are collided with some kind of neutrons or electrons, what happens? They will start their chain reaction. Now, what happens in this 3 Mile Island nuclear reactor? 50% of the core has been melted down because the heat is not properly moderated. When the heat is very high, we have to insert the control rods into the moderator, or we have to insert them into the core, so that the temperature of the core will be removed. If the control rods are not inserted at the time, when there is a high temperature, the core will be melted down. Whenever there is a melting of the core, all the metal pipes inside the core will be melted, and this causes the entire chain reaction will be not at all controlled. Okay. So stuck with wall with no indicator. Here there is another thing happened in this reactor. 50% of the core has been melted down, but the indicator has failed, showing that the temperature is very high. So that is when water is not released, but containment vessels are very strong enough. The entire outer containment tank, this one. So inner core has been melted down. The outer containment tank is very strong that it does not break anyway. So that however the meltdown of the or the blast of the nuclear power reactor has been controlled somehow because of the failure of the indicator which indicating the temperature. So the failure of this indicator has created a very dangerous situation where the entire nuclear power plant will be going to explode. Now, more sensors added for better communication to experts, and do not turn off emergency cooling. So in any manner, we have to use more number of sensors in order to identify the temperature inside the nuclear core. Because the temperature inside the nuclear core is not monitored perfectly, it may lead to explosion of the entire power plant. They not only explode, they will emit radiation into the atmosphere, which will create skin cancers for the people or the animals living around the nuclear power plant for up to a distance of 5 kilometers. Depending on the size of the nuclear reactor, it may go up to 10 kilometers as well. And so this is another point, 28-year US safety record since incident. Since this accident, this is a minor accident where it is controlled with the help of outer tank. However, the plant may not be useful because there is huge radioactivity in that area. So that is why this after this the safety measures has been taken. So further no such incidents has happened in the United States. So this is mostly done. This has happened in the United States. That is why after 28 years no such accident has happened. Now another situation in Russia. This happened in 1986 where there is a city called Chernobyl where a nuclear power plant has blasted. So there is one stupid action done by human which lead to this reaction or this incident where the operator has turned off the cooling system. The operator who is working at the cooling system reactor, he knowingly or unknowingly, he turned off the cooling system. That means the cooling rods are not inserted into the core when the temperature is very high inside the nuclear reactor. So that is when the steam cooling reactor designed allow unstable steam pockets to graphite caught fire. So what happened? When the cooling system is turned off, the heat inside the nuclear reactor has risen so high that it burned the entire reactor. The reactor and the lining around the reactor is made up of graphite, and this graphite has caught fire. Graphite is an element which contains large amount of carbon. So it is a combination of carbon. So this graphite has caught fire, and this has finally led to nuclear explosion. So, and this kind of design is not used. So the one thing we learned from this Chernobyl incident is the same design is not used anywhere in the world because it has failed and it has killed a lot of people. This Chernobyl reaction or the Chernobyl accident has created the entire city of Chernobyl to be evacuated. Up to 20 kilometers of radius around the nuclear reactor has been evacuated, and till today there are no people living in that area because of the high radioactivity evolving from all over the place. Around 10 kilometers to 20 kilometers of circumference of the city around the nuclear power reactor is still emitting radiation till today. This is 2023. This has happened back like 30 years ago, 35 years ago. Still the radiation is being continued. So the radioactive elements are very bad that any radioactive element will keep on producing radioactive nature or radiation for up to like 200 to 400 years. Some may reach up to 700 years. So that is the capability of any radioactive element, where they will produce a very high radiation for like many hundred years. Okay. So this radioactive nature or radiation which is evolved from the radioactive element is very dangerous for humans, plants, animals, or even any metals. Metals also get corroded with the radioactive nature. So we remember a scientist, Mary Curie. She is popularly called as Madame Curie. She is the one who accidentally, she invented this radioactive elements like uranium 235. So when she was doing an experiment in her lab, she has unknowingly made some reactions with the uranium and found that the uranium metal is giving out some radiations which are very dangerous. These radiations can cause skin irritation at the beginning of the time, and after it goes into the skin, it will cause cancer to the skin. Now, she made some research. She found that the uranium is very dangerous. Along with uranium, she has found some other materials that are very dangerous, as dangerous as uranium. They're all called as radioactive elements, or they will produce radiation, which is very dangerous for humans. Even she had some research. She wrote some papers, and however, she has invented this, but she cannot escape from the radiation of the radioactive elements. She was killed by cancer because of the radiation which is emitted, and she got all the radiation on her body without knowing. So that is when Marie Curie was dead because of the radioactive nature of the elements she did experiment with. Even her books or the tools she has used for the experiment in those days are till now giving out radiation till today. After 200 years of that time, still today the radioactive nature is still going on. So finally, any radioactive element has to be used. Any radioactive element has to be used wisely. If it is not used for good reason, it causes very bad situations. Even in nuclear power plants, by mistakenly, lot of accidents has happened. One incident has happened in Japan, where a nuclear reactor has blasted, and till today the nuclear reactor is emitting a large amount of radiation. So this is how, when these radioactive elements are very dangerous and they are very helpful. Very small amount of uranium can create a large amount of electricity, but yet they are so dangerous that very small amount of nuclear element can cause a big explosion which can be used as nuclear bombs. So we as an engineers, we have to use this science or technology for the good of humankind, not for killing people. So that is all for today. We'll meet in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.